Опа. Okay. Okay. Yeah. So so here is the slides. Majority of people were like Russian, Ukrainian, Armenian of community in LA, but there were also some like one English speaking engineer from Intel, and there was also a former Samsung intern who is now working in LA in a different electronic company. So to those people, I just gave them some like tasks to do that quiz with the questions to just evaluate how good the questions of interview process. And for the rest, I gave them presentation which shows first setup with so like demo boards, and then setup with tank. Yes, hi Philip. So like I'm talking about presentation in LA right now. Then I made a setup where they connect a display to TM1638 and to this board. So this is like easy to connect. So like I can just give it to like everybody, and they can play with it. But unfortunately now I realize that I forgot to tell them how to insert the screen. So many didn't insert. They're just looking like what I'm doing. So then I gave them this simple instruction how to connect 5 wires. And I also told them that if they want to connect the full sync, they can connect to each individual peripheral. And then I also got SSD drives, bootable SSD drives, so they can connect to computer and load. But apparently, like many like young people have Apple Macintosh. But even for Apple Macintosh, we can use open source tool chain for Gorin, which does exist, and they did try that it works.
Okay.
Yeah. I mean, I didn't try it. Yes. So this is available in Yoshi's headquarter. So there is the GitHub Yoshi's headquarter. GitHub Yoshi's headquarter. So GitHub Yoshi's headquarter. So if you go to this Yoshi's headquarter, and if you click to OSS CAD suite, and if you go to releases, so with releases, yeah, OSS CAD suite build. So if you go to release, which is latest, so if you click here, you can see those builds. And there are builds on Darwin, which is Apple Macintosh, both ARM-based and x86 based.
Nice.
Yeah, and Linux on ARM and Linux on x86 and Windows. So they can just download this, and it does work. Also, it is sort of like buggy on many examples. So it can be used for small examples. But it's difficult to use for like large examples, because then you need to mess with this. Yeah, but this is stuff for us to run it under on Upper Macintosh. So one direction we should do is to get many people who have like Upper Macintosh and run examples on Upper Macintosh.
Yeah, it just as soon as you have, I can run it on ARM64, and it's macOS and Linux compatible. It means that we can use Docker.
Yeah, but Linux is better to run like Linux native thing. Yeah. So, but you should test on Darwin. It's for sure. Yeah. So now, next thing. So I explained main idea of HDL-based design flow. So this is like so software and hardware, and then software you compile to this set of instructions, and hardware you compile to GDS2 file. Then I explained main idea of like digital logic, that you have combinational cloud and state registers. And combinational logic, you just put something on wires, wait, and you get the results. And the problem is that when do you get the results? And we are using clock to make computation deterministic. And we use sequential logic to repeat actions. Then I explain counter. So one good thing about LA is that I actually hired professional videographer who made video recording of everything, and he is also is going to make promotional videos.
Nice.
So like short promotional videos and wide and like photo pictures and stuff. So I expect some materials from him within like 2 to 3 days, and you can use it for like many purposes. Yeah. Now, oh, plus I also did recording over Zoom, so we have recording of both lecture and video like of the screen. Yeah. So now manufacturing and options for the chip manufacturing for commercial and like Euro practice, Moses, and this Skywater, and like commercial versus free tools. Then I talked a little bit about tiny tape out, and this is something what I need to do like today or tomorrow. So tiny tape out is the way to create ASIC for like regular folks who cannot spend like $1 million on manufacturing. So essentially, it uses shutter service, but it gets the chip you can do with shutter service for like 10K, and it splits it into many sections. And you can buy one section for just $150.
I see. So like many people have their own small part of the thing. They're all on the same chip, but you just use your own part.
Yeah, and you just use external pins to tell the chip to get results from there. Yeah, but you can also run like everybody else designs as well.
This is a very cool idea.
Yeah. So this is something what we actually need to do probably today, or at most tomorrow. Tomorrow is a holiday, so I can do this tomorrow. Yeah, now chip design team. So how like chip design organizations look in different companies. So we have department, then member of each department in a chip in a group associated with a block. And in each group you have like a block microarchitect, and you have he also frequently writes the code, and you have design engineer, and they like debug block together, and then like modeling engineer, verification engineer, and the block microarchitect work together as a team. Then you have physical design engineer, and RTR engineer works with physical design engineer. Then I explain concept of FPGA. So like there are ASICs and FPGAs, and what is inside the FPGA cell, and lookup table, and then I talked about Ruslan Palatak, who helped me to work with this Goyan open source tool chain, and he also created open source board and uses like lattice FPGA and so on. Then I talked about books to prepare for interview. So I met with David Harris. Then I told about like other books and about book by Donald Thomas and verification books and books on special topics. Yeah, here I actually expected Ben Cohen, who is author of book on the left, to be present on LA Meetup because he put that he is going there on a LinkedIn page, but he actually didn't. Yeah, there's also like special topics. They're usually not applicable for the students, for recent college graduates. Also, some students put formal verification on their resume that they can write system Verilog assertion, but then I ask them to write simplest one assertions, and they have no clue. So they probably just put it there because they think that nobody is going to ask. And some people like me do ask. So yeah, then I recommended articles from Cliff Cummings, and then I explained that there is a gap between like academia and the industry. And here I should put like 5 more slides about problems students don't do well. And then where it is used, that I put about Verilog meetup at a Hacker Dojo, and that we are going to have event at Makers Fair. Like I mentioned here, Philip, because that shows that we are reaching many like countries around the world. Then this seminar in Azerbaijan, seminar in Georgia, seminar in Kyrgyzstan, together with Siemens, and the seminar in Russia in 23 places in the Belarus. And mentions that they can go to Maker Fair on October 18. Yeah, and that's it. So those are the slides. So what do you think about the slides?
Good.
Yeah, so this is like 3-hour lecture. So I have a recording. And so if I go to Zoom, login.
And the recordings are in the Google, right?
Recordings, I put them on YouTube and then send the link. So if we look to this recording, yeah, so this is exactly 3 hours, so 3 hours and 2 minutes. Yeah, so which is good. So you have this recording both of screen and my slides, and also a videographer like recorded everything. So we have that one, plus he is going to make advertising videos and photo pictures. Yeah, so we got a lot of material which can be used in different events. Okay, so this is pretty much it about LA. So what I want to do now, I want to test boards. So now let's see what. Wait a second, this is incorrect count. So now let's see what boards are tested and what boards are not tested. Okay, so one thing which we have to do is to to adopt a Linux board as soon as possible because this is used in Azerbaijan. So board in Mira is under control. Basis 3 is not implemented. I want to give to somebody else. Cyclone 5 used in Armenia. I think we put it everything under control, but the person in Armenia need to test it completely. But she actually tested this as partially, so we can put tested partially. Yeah, so if something doesn't work, so we can put this as under control. Yeah, so rest I think she needs to test. Can put it partially. We can put here check. Yeah, this is done. Yeah, so this is done. So this is CMod 87 if somebody wants to do it. Yeah, now D0, I think D0 is working, I believe, but it needs to be tested more. So graphics updated. So the thing that yes, the thing that D0 is done, and this is also done. This is done. Yeah. So with the D0, you can put green everywhere. So now with D0 Nano, with D0 Nano, we need to put this like lower priority because I don't think many people use D0 Nano, but there are people use D0 Nano. Yeah, D0 Nano SoC, this is all like up to Alexander Kirichenko. So I rely on him. This thing, D1. Yeah, so you have D1. So D1. So Pete Chelonit together with me implemented D1, and we actually can now test it again.
Last time.
All
the way up to the graphics, everything just worked.
Okay, good, excellent.
Examples.
Okay, good. So let's just put it as green. Everything. So this is all works. So wait a second, what was this? D0CV. Let's actually put this column. Copy. Paste.
You can also freeze the first column.
Yes, you know, I can freeze the first column. Yeah, let's freeze the first column. Second. Where is the freeze option?
Maybe more. It has to be
Yeah,
somewhere.
freeze. Yeah, this is the freeze. Okay, in this case A, I can, this case V, I can remove from here. Just delete column. Okay, so this is frozen. Okay, now let's see. Okay, so this one, we assume this is kind of under control. Yeah, this is something which has to be done. D0CV. D0CV, I believe I review it. I believe I review it. And but this needs to be tested. But actually, I tested it. So this is kind of under control.
Could you also please the first row?
Oh yeah, sure. Yeah, okay. So now we're in good shape. Okay, so now okay, so G10 Lite I tested and it looks like it's working, but needs to be. So I did the review, but I didn't do complete test with all microphone and output. So this is
We
kind
have
of
not verified microphone on this board.
Yeah, let's put board and let's verify it now.
Okay.
Yeah, so I can give you microphone and everything, and you can connect and verify. Yeah, so let's do this as the very first thing right now.
Okay. So this is G1. Use the G1 to do microphone. Okay, to do microphone. Okay. Yeah, today I didn't like I forgot to send notification about meetings, so many people probably decided that there is no meeting today. Okay, so G2, I think Pete didn't finish it. If he doesn't finish it by 15, then I will finish by myself. Yeah, D2115, I think I tested it, but we can test it. So let's actually mark what should be done today. So AX 4010 probably no. CMOD D0. So D0. So D0 we can test with microphone, but I think I did tested it. So let's put question. D0 CV, I also think I tested it. So D1 is, you need to test D1. D1 SOC. I think everything is. I did review. Okay, we need to check here. I think I did everything, and I think everything here is also under control. And this is green, and this is partially, but we can probably test it as well. Okay, so this one is okay. So D10 Lite, we can also test it. So this is partially. D10 Nano, I rely on Alexander Kilchenko. D2115. This is partially. So let's actually together test all of this board, because I have all of them. Just question of connecting microphone. Yeah. Now, yeah, this DK Dev 3C120 and board is something weird. It's something which marketing manager in MIPS gave first to my friend Sergey, and he gave it to me, and I gave it back, and I gave it to like another my friend. He gave it back to me. So this was moving between many people, and then like 10 years later, I found that this board is used in Nizhny Novgorod. This is actually a very expensive board. It costs like around like $2,000, and with accessories like $3,000. So in
or like $1,500. I don't remember, but some. So probably if this is $1,500, they in Nizhny Novgorod bought 6 boards for $10,000 back in like 2006 or something when this board was manufactured, and then it was just sitting there. So I ported examples. I have this board, so I recovered it from my friend, but I don't think this board is suitable for all the examples because I was never able to put graphics on it. So this is very low priority. Then we have another board which I want somebody else to work with because nobody except me is using it. Then this board is on Ruslan Zalata, and I think that he already implemented it. So Ruslan, but I can test it, but I need to get this board today. Yes, partially. Yeah, so this is kind of yellow. This is kind of green. Okay, now Karnik's it's all Ruslan business. It's whatever he decides. Nexus A7 I implemented, and graphics updated. Yes, graphics updated. Yes. Graphics updated. Yes. Graphics updated. Yes. Okay, so now, yes, Samdaz, I think Samdaz is kind of partially, so you can put it as yes, Samdaz we also can test today with everything, so you can try to test on those. Yeah, Nexus 4, I tested it partially, so this can be retested, but generally this is green. And same thing is Nexus 4 DDR. Same thing Nexus 4 DDR. Okay, now Peace Word 6, it's something rare board I have, but there are some people using this board, so you should have support. QMTech started not necessary. QMTech Kintex 7, it's on Vladislav Terekhin, but I don't have anybody else who is using it. Run Bear, we don't need. Savings I need to get from Alexis as soon as possible and test it because this is used in synthesis school. So now let's see what is the problem with sailings now. Click pull. Today's Labor Day weekend, so many people went somewhere.
Yep.
Okay, so there is nobody. Oh, okay, this is fine. Okay, now sailings. So sailings. No, sailings is not updated. Settings need to be updated as soon as possible. Settings needs to be updated as soon as. Okay, so with settings we put everything red, and with settings we put that everything should be done as soon as possible. The settings is the highest priority.
Why?
Because the settings is used by many people. So like OM does settings are highest priority for sure.
Mhm.
Yeah, step max 10 it's like later on. 10 mega 138K. If you want to take care of this board, I can give it to you. This is a good board, but I simply didn't work on it yet. So 10 mega pro 138K is doesn't have HDMI, but so it's a kind of okay. Now 10 nano 1K was partially implemented. 4K Victor has some problems. So same thing. 10 nano 20K is actually also high priority. So you also need to put it as a high priority board. Okay, so 9K is in good shape generally. So you can put yes, tested. Yeah, so tank primer. So yeah, so tank primer. This was on that one. Maxim. What is his name? Just a second. This is all implemented. So GitHub. Yeah, this is something we also need to test as soon as possible. So tank primer docs. Tank primer 20K doc. Oh, wait. Need to go to new. We need to go to new graphics branch and see. Yeah. So there is a tank primer 20K doc HDMI, no TM16 HDMI with, and then wait, no HDMI. What is no HDMI? He means with LCD screen. Or did we decide to just use HDMI? Sir? One second. So GPU. So he put only HDMI. Yeah, let me. Yeah, this is another which we should test today, preferably. Instantiate graphics interface module, VGA, HDMI, microphone. Okay. So he actually implemented only HDMI. Yeah. So this is Maxim Kudinov. So So let's put here. Yeah, this is another thing we need to test right away. We need to test this today. So I think this is kind of in good shape, but we need to test it today. This is something to do. And this is red. Okay. And okay, yours is option 16 graphics updated. LCD support HDMI, so this is with HDMI. And we need to check. We put here and here we put red color. So this is something. Yeah. So let's investigate what is going on with the tank primer 20K dock. So with tank primer 20K dock. Okay. So with no HDMI. Uses common code. So this is the main code. Graphics interface. Yeah, so VGA, HDMI, microphone, and no audio decoder. So this is something which has to be done. And okay, yeah, this is something which has to be done. Yeah, let's put to do. Let's put here X. Let's put here green. Yeah, so this is something which we need to test today. Yeah, then yeah, this is okay with the 25K. It is important because we are going to show this during Maker Faire. Yeah, I think Ziova is under control now, but also has to be tested. I think Ziova I did review. So let's see what I did with Ziova. Oh, sorry. Yes, this configuration I probably need to remove. It's some special like handicapped configuration of a broken board I have. So now oh, actually this is not reviewed. I need to review it again. Yeah, Ziova should be reviewed. So I need to review Ziova. No. This is generally sort of under control, but should be reviewed. And about Zybo, I think it's a good shape. So Kieran did Zibo. Second, what do you have in chat? Okay. Victor, what was your question? Что вы хотели спросить?
Да я там увидел танк, праймер, док, но HDMI. А смысл такой делать, если у него HDMI прямо на этом? У лайта, да, я согласен. Может быть вариация с HDMI без HDMI. А у дока-то он у него прям на доке, на
Он у него,
самом.
так если на доке, может, там не нужно даже LCD делать. Если это, ну, да, тогда смысла нет. Все, согласен, удаляем. Короче, я спрошу Максима, потом мы удалим. Окей, да, это нужно внести в таблицу. Потому что это просто лишняя штука в таблице, ну, среди плат. Okay, so tank primer dock. Okay, ask to remove non-HDMI option. Okay, do you have any LCD on the dock? So tank nano 20K dock. Yeah, tank primer 20K. Tank primer 20K dock. Oh, yes. It does have display. Это стоит сделать с LCD. Okay. Okay. Okay, LCD. It's kind of low priority, but probably to do. Okay, this is not tested. Yeah, but this is something you should test right now. Or maybe I should review it first. Graphics updated. Yeah, let's actually test this first and review. Your tank primer 20K dock is important. Okay, so Zibo. Yeah, Zibo, good thing about Zibo, it is used in Minsk University, so they can now use Zibo boards in there. Yeah, okay. So now let's see. Okay, so let's start with D0. So let's actually put all boards you want to test today here. Okay, so your board. Wait, do you have a computer with you, or do you use something? Yeah, okay. Let me use marker. Yeah, so I will give you a computer which is a Windows computer, and so you test it first for Windows and then for with the Linux. Oh, wait. What?
I don't have a laptop.
Yeah, this yes, I have it here. Yeah, so this is the laptop. Okay, this is laptop. Now let me give you a power supply. Just a moment. That's got it. So let's put this. Let's put it there because I want to put boards there. Now let's sort it out. I think this one is the right power supply. Okay, so connect this power supply. Yeah, so while you do testing, I will start to write to work on tiny tape out.
Few questions.
Just a second. Let's get first all the components. Okay, so now this is bootable SSD.
Yep.
Hi, Pete. Yeah, so this is bootable SSD. So we are today we are going to test many boards. So we start with the D1, and connect microphone and everything. So everything we did with you. So like Timothy, you start with this board. Yeah. Now, in addition to D2, so I mean D1, let's do the following. Okay, so first D0. Did I test D0 with all the microphone and so on? Okay, so here is D0, and let me see if I have microphone for it. Oh, okay, so this one is the D0C. Yeah, so let's start with that. Yeah, so this is D0CV, and now I want to connect a microphone and the audio to each board. So like do not move microphone and like audio between them, just to connect to like each of them.
Okay.
Yeah, so let me just give you a bunch of microphones and bunch of audio decoders. Okay, so yeah, so you can like look at this as reference. So you see, I just connected here, just I left it here. So you can do the same thing.
You do not want to use the built-in ones, right?
Actually, I want to use, but the problem is that we need to put a Verilog code, some Verilog modules for this thing. So we like already have support for microphone for this like INMP, but I don't have support for that board. And because that board is old, it makes no sense to make special module for this board. Yeah. So we like assume that if somebody has this board, it's easier for them to buy microphones than to ask to create support. So now let's see boards with existing support. Oh, we also need to test microphone on D1 SoC if it's implemented. Okay, so let's see if microphone is implemented on D1 SoC. From D1 SoC. This is red. This one is red. So do you want to connect audio decoder on D1 SoC?
First,
Yeah, let's start first with this board. Yeah, okay. Okay, so with the D1 SoC. Okay, so let's see. So first D1. So let's see the status of D1. D1 is supposed to be in the first. So we put here just action priority. So one test everything. So one is this is page number one. Page number one, test everything.
Yeah, somebody joined. Yeah, so G0. Yeah, so G0 we also need to test, but this is lower priority because this is also tested by other people, including Mikhail Grafov. So we need to test everything. No, next. So G0 test everything. G1. So what's G1 SOC? So let's put like 6 implement audio out everything. This like next time. G10 light. G10 light everything is implemented, so we need to test everything. Okay, so G10 light is number 4, test everything. G2115 G2115, I believe I tested everything. So when you test everything, what you can do is that you need to test like graphics, music input, music output. So like no graphics output. Yeah, yeah. So with a 7-segment display, you need to test like 5 or similar thing. Yeah, 5. We need to test 5 because we need to make sure that that also like 7-segment dots work. So 5 for example is an example which is in a lab. So this is a micro architecture example. So this is in labs microarchitecture FIFO. Yeah, so FIFO is a better debug, which is 423. 423. Yeah, so to test graphics, microphone, then sound output, and FIFO is better debug, and you need to connect microphone and sound output to each board. So you can figure out the location from board documentation from QSF file. And if pins are not documented, then you need to get those pins from Jurassic website. Okay. Okay, so with the D215, it is tested, but not completely, but completely. Test everything. There is a test called FIFO is battery debug. You can see how it behaves. Okay, next, on that should be tested. So we have 1, 2, number 3. So on that is supposed to work. And on that PMod microphone 3 is supposed to work. So thinking on that, you also know. Does the thing I test, so does is a low priority because also Mikhail Gaffer is doing testing. Yeah. And for D and for Amdaz, I think everything is connected. I think Amdaz is okay. Let me check. Oh, this is you definitely test doc today. We probably need doc VGA because we have already doc on HDMI board. Yeah, this is our next priority.
So for the FIFO, what is it supposed to do?
No, you got a regular FIFO. You need to get a FIFO with better debug.
I think that's the one I've just installed. Let's double check that. FIFO with beta debug 1.
Yeah, FIFO with better debug 1, so you can run
FIFO
it.
with beta debug 1.03.
Maybe this is it. Yeah.
So what is it supposed to do? I press
Let me
different
show you.
buttons
Let
and
me
it
show
doesn't
you.
make sense.
Yeah. But this is not it. No, this is it. Yeah. So you push number, which is number and list. So you push number and then you pop number. So you push 6, 7, E, C, and then it's full. And now you pop from the right. So you pop 6, you pop 7, you pop E, you put C. Now it's empty. So you push data and you pop data. Yeah, so this works just fine.
Okay.
Yeah. Okay, that's it. Okay, this one is fine. Okay, so let me give you microphones and connectors. There's also female to female connectors. Please. Okay, so those are microphones and sound output.
Okay. Then how do I figure out where to connect? Here it says GPIO 1 from 0 to 5 reserved for my. Can you click on your project?
Okay, now what you do is here you see okay, your reference. So this actually doesn't have a documentation where so you're going to
I only see SOC.
no, this is D1 SOC. It's a different board. You Google Terasic D1. So Terasic. You do what Terasic, TE without TH. Terasic yeah, D1. No, not SOC, just enter. Okay, so then go to their website here, Altera D1 board. Then you go to resources. So you download getting started user manual or board introduction. I'm not sure which one. So you download manuals from here.
Okay.
Yeah.
And what you should tell me?
Now you look into manual. Okay. Okay. This one doesn't have anything. You go to different manual.
Let's try this one.
Mm-hmm. Okay, yeah, this is user manual. So you go to pins. No, more. It will show IO pins.
This is all for the programmer.
No. Just like a search for GPIO.
Okay.
Yeah, here.
Excellent.
So you can go like a little bit up here. So here you can see pins, or go down, and you can see table of pins. Oh no, go up. Yeah, so you can actually look at here.
So this one is GP2.
So this is GPU 0. This one is GPU 1. GPU 0, GPU 1. So
Okay.
you can see that this is
Okay.
GPU 0,
Yes,
GPU 1,
yes.
GPU, yeah. And then you look at here, and then like you need to make a screenshot of the thing and send it to me, so I will integrate it into boards. And then you look like IOA0, then you go to QSF file.
This one, right?
Yeah, QSF file. Yeah, and then like you can see. Okay, so was it?
I think you downloaded the map, no?
Huh? Yes, this is the map. Yeah, so go here. Okay, go GPU 0 A13. So go back to that file.
Okay.
So where is A13?
Yeah.
Opa. Oh yeah, this is D1. And are you looking to D0?
It says D1 user manual.
Yeah, D1. Now let's go back
So
to QSF. Yeah, let's go back to QSF file. What?
This doesn't look right, right?
Yes, this doesn't look right. Something is very weird. Okay, can you go to D1 default QSF for reference? This one, can you search same thing here?
Same thing.
This is it. Maybe different variants of board have different pinouts.
That is possible, but this was, how can we tell? We can tell, because if you go all the way up, they will have screenshots of the board, and this is our board.
That's weird. Anyway, what I recommend to do in this case, let's figure it out. Hi. Yes, yes. My name is Yuri.
I'm Chuck.
Okay. So what are you generally doing, and what is your interest in Verilog Meetup?
Just trying to see what kind of test of system design about Verilog.
Okay. So, but how many knowledge about Verilog? So, what do you do professionally?
I work on the execution unit or the floating point.
Okay. So you're like already proficient in Verilog, right? So which company are you working in?
I'm looking for work. So I was working with Meta.
You're working with Meta. So does Meta do process or course?
Well, they were doing prototyping with AR, VR on FPGA.
Okay. But what core was it? Was it like a RISC-V core?
No, the project I work on only the AR, VR, not the BISFI.
Huh?
The project that I work on for Meta was the AR, VR, not the BISFI.
AR, VR. Okay. So this was some like a custom AR, VR accelerator for FPGA, right?
For the project I work on, no, but for the type of work I used to work with, that was for the accelerators.
Okay.
That's a little different there.
Okay. Yeah. Let me actually explain what we do here, like a little bit. Yeah. If you can sit down. So we are preparing like a set of educational materials for mostly for like professors who teach students. We are prepared with FPGA boards. Those are very same example that work on different FPGA boards from like different vendors. In those like in those educational materials, we actually are trying to cover three different areas. One area is like introduction for people who like don't know FPGA and just started to learn Verilog and FPGA. So this is the first thing. Second, we also create infrastructure that the same Verilog can be implemented on very many. And the third thing is that we create examples that help students to pass job interviews. Because let me show you type of question. So if you for example, I personally for Samsung, so like I interview like a lot of students, and what I did notice is that if you give for some students some like valid ready type of questions where you have like control flow. Many students are struggling. Like this is like very simple question. Like if you give them some narrow stream of data to convert into wide stream, some of them are struggling. But this like question is not particularly difficult. What really makes students struggle is the following question. So like I asked them, like pipeline block, each computer square root. After this, what do you do if you compute with dependencies? Like if you result of one square root with different square root, and they draw something like this, but this isn't going to work because a pipeline. So you need to put 5 register here, yeah. But they usually like are not trained in school. So like in school they trained what is the FIFO, but they don't know how to use FIFO. You see, so basically we create set of examples of this nature, how to use FIFO, use credit-based networking company, GPS, like everywhere we use, we do everything using a credit-based flow control. We use this one. So, show you.
Do you know something about the cache design?
We don't at the moment, but we are looking for it. So if you can make an example with like a fully associative direct cache, this would be great. Yeah.
I'm currently looking into the cache design. I don't have much experience there, so that's why.
Ah, really? So for cache design, the very first thing what we can do is that like version like fifth edition of Hennessy Patterson had appendix on cache design. So let me find it for you just a moment. So Hennessy Patterson appendix. Hennessy Patterson appendix source code. Just a second. It was okay. It should be in my links.
Basically, it's like four-way association.
Yeah, so that one is a direct cache, but then you can convert it into a four-way associative. Yeah. Yeah. So now just a second. Let me find it.
I mean, I was looking online all
Let me show you one example. Here. And that's this one. There is also open hardware website with RISC-V core created by David Harris and other people, and that core may have such cache. Let me just find this one. 1 second.
I was looking at. Oh wait, is it this one?
This is a different one. Just a second. Let me just find what I wanted to show. Okay, let me turn off stop share because it's just confuses. Okay, just a second. So hey, yeah, here. So we're looking for article on cache design. 1 second. Where was it? No, it's different. You're looking for a specific article.
I'm just trying to look at some general cache.
Yeah, this is what I'm trying to find. Just a second. Because I have this article, and maybe this can be starting point. No, just multi-way cache. Just a second, I will find it for you.
Well, the cache coherence is also even part of the file online because theories.
No, the frequency is for multi-core on the of course, yeah. 1 second, I find. Yeah, I don't see it right away, but I can find this article for you later on. Yeah. So we have some. Which source? Yeah, this is source for caches. So this is cache way. So this is one of the things we want to convert. So you see, this is a cache way. So this is one of cache way, and this is created by David, who is the author of a textbook like that one textbook. Yeah. So maybe you can like take part in working on this code and put it on FPGA board. This is a good way of learning this thing, because David Harris is finishing to publish a book which completely describes CPU, and one part of this book is this caches. Yeah, so you have to work on this, and if you want, you can like join us and work on this thing. Yeah, this is called open. This is something we have to do anyway. You see? Hi.
This is the one that I found.
Okay.
There's instructions for using this board.
Uh-huh.
So I have this one, which has the same.
Yeah.
Are wrong.
Yeah, pins are different.
The same FPGA.
Show you how to implement for like basis 3, and then you can implement yourself for RT A7.
Basis 3.
Yeah. So I have another board which also has RTX FPGA, and this board is called Basis 3. This one. So they all have RTX 7 FPGA. And I do have a task to make this board compatible with all the examples. And I can show you right now how to do this. But then you need to do exactly the same thing for RT. Yeah, so but the method is the same. Okay, so now you have actually all tasks on hand. So let's actually start with you. So with you, we need to figure out.
I figured it out. It's okay.
Yeah.
So we have changed from 0 to 35. It's second header. And here are the same pins. So I just need to understand this as GPIO150 are reserved for Mac. I know which pins these pins are. So how do you connect the microphone?
So in order to see how you connect microphone,
So you really need to know
I know.
what pin here. So you
Yes, I
connect
know.
with those like a female to female jumper. So
I know.
what you do is okay, good. So you get a female to female jumper. Yeah. So here is a female to female jumper. So you get those jumpers. So you can get like those short jumpers. You get the microphone. And you just look at pins here. What you put jumper here.
So the difficulty is on the microphone, there are no numbers. And the source code just says GPIO 1.
Okay, so go down, go all the way down. And here is a microphone.
Oh, here it is.
No,
I see
up,
it.
up. No, this is not a microphone. This is audio to this microphone.
Okay.
So you put GPIO 10 is LR.
Okay.
So here you have LR. LR is here. And like generally it's supposed to be connected, like 3 jumpers go from here straight to here. Okay.
Okay.
Yeah. So this book has cache design in chapter, I think 8. Yeah, cache design. So just go to chapter 8, and in chapter 7 you go to chapter 8. Yeah. Yeah. So it shows that processor speed was faster than memory. Performance analysis, and then it shows like direct cache and then multi-way cache. So like it does have like you see like associative cache and like direct cache, and they have some code for this book, but this book is too much elementary. They have next book, and this next book they are more serious about caches.
Oh,
Yes, like in fact, I have his book manuscript, but he asked not to share it. And this book will be published like before the end of the year. But the code for the book is the code I just showed to you. So this is the code with the cache race. So like basically this all is documented. So like I will look at it, but you can look at this code in this cache way, and then we can together to connect the CPU for our FPGA infrastructure. Yeah. So can you give me your email? I will put it into mailing list. So what is your? Yeah. So let me do it. Yeah. Uh-huh. Okay. Yeah. So what we can do is that first, like you can get like this book from someone. Yeah. Unfortunately, I cannot loan you this book because like the author made the cosograph, so like I want to keep it, but you can get this book and read it, but this is like probably too simple for you already. Yeah.
Something more advanced.
Yeah, so you need something more advanced. So that book is not published. You can see some material in like Patterson Hennessy. So, but let's see. But you can get a lot from like analyzing of this code.
Mm-hmm.
Yeah, I have a couple more cache. The you can get stuff analysis of this code. Now, like documentation, yes, so this is
Okay.